Welcome to Pure Aqua's Learning Center. In this series of videos, we will cover top-mounted control valves. This particular video will cover the Fleck 2850 control valve, which is manufactured by Pentair. We'll cover 5 main points in this video. 1. The valve specifications. 2. Installation. 3. Programming. 4. Troubleshooting. 5. Service and rebuild kits. Pure Aqua has chosen the Fleck 2850 control valve because of its cost effectiveness and extreme reliability. The valve is manufactured out of a lead-free brass valve body for superior strength and durability. This particular valve is part of Pentair's commercial control valve line, which is ideal for small commercial and industrial applications. The valve can handle flow rates of close to 50 gallons a minute in both service and backwash, which is typically in the range of 24-inch tank filters. It comes with a fully adjustable 3 or 5 cycle control system, which is designed for single and multiple tank systems. The Fleck 2850 can be equipped for a filter or softener, but in this video we will be discussing the filter option. This can be equipped with a no hard water bypass piston, depending on the downflow systems and the exact application. The valve has 4 different types of controllers: the NXT, the SXT, the XT, and the basic electromechanical timer. The Fleck 2850 valve comes equipped as shown. On the front side you have your valve cover, controls, and control board inside. Moving to the rear side of the valve, you have 3 connections. You have your inlet and outlet, which are 1.5-inch female MPT thread, and the drain on the valve bodies is 1 inch but can come equipped as 1.5 inches with a bell reducer based on the capacity of the system. The steps discussed in this segment of the video will cover everything that is needed to get this filter online and installed. So going through these components we have shown here, we have our 14 and 16-inch tank distributors and laterals. Now, it is important to note that these are generic for 14 and 16-inch tank, but of course depending on the tank size that the valve will get installed on, these internals or laterals will get sized appropriately. We have our 1.5 inch riser pipe, which gets installed onto this hub. We have our 110 volt transformer, but of course this can be equipped for 220 based on the location and installation. We have our drain line flow control, our distributor screen, and our strain relief fitting for the transformer that gets installed in the back of the valve. Step 1 of the installation procedure would be to install the drain line flow control. Again, this is a generic 15 gallon per minute flow control. However, many different sizes can be used, including a 2-inch. But in this particular video, we're going to show a 1-inch. So when installing this, of course, Teflon must be used with some kind of sealant to prevent any leaks and securely installing the drain line flow control. One very important thing, of course, when installing this flow control is paying attention or close attention to the direction of the flow. So since this is the drain and the flow direction will be coming out of the valve, the direction must represent that. So since the flow is coming out, the flow direction is pointing out, and essentially the water is leaving the tank and going to the drain. Step 2 of the installation procedure would be to lubricate the 2 O-rings on the valve body and install the distributor cone. So the 2 O-rings that need to be lubricated are the inner O-ring here and the outer O-ring here that seals the tank and valve. So the recommended lubricant will be the Dow 11, which is an excellent lubricant used at Pure Aqua here for various O-rings. So once these 2 O-rings are lubricated, the valve distributor cone gets installed here. So when installing this cone, you must push these tabs in and make sure, of course, that the cone is properly aligned and straight. If not, it'll be a little tricky to install this properly. So once those tabs are pushed in, the cone snaps into place and actually cannot really be pulled out unless these tabs or locks are pushed down and the cone is removed. So once that's done, that completes step number 2. Step 3 of the installation procedure would be to install the power cables coming out of the transformer onto the control board. Again, it is assumed that there's absolutely no power coming into both the transformer or valve, and it is safe to work with the valve. Now, when doing so, there is a small strain relief here where these wires get routed through and must be inserted and brought in from the back of the inside of the valve body. Now, once the wires are routed through, the wires must be pulled from inside the valve. So to do so, the valve cover must be open, and this just takes a small flathead screwdriver, and once that's open, you just simply open the valve body cover or door, and it's hinged, so you can just move it over to the left. After that, the wires get installed onto the back side of the NXT control board. So to do so, there's a small screw here that basically holds this onto the valve body back end here, and must be unscrewed in order for this to be opened as well. Again, this is hinged as well, which makes it very convenient. So this opens up to the right, and once the wires are run through this, they will get wired onto here, which we will show shortly. Once the power cables have been run through the strain relief, there's 3 wires here that will get connected. We have a ground, which is connected here, and that's marked on the back side of the valve, and we have our 2 power cables that get connected on the control board. Now, it's very important to note that there's several places that look very similar on where these can get connected, and only one place can actually accommodate these because the board will get burnt. So on the lower right hand part of the board, there is the connection point which says 24 volt AC. Again, the order of this does not matter how they get wired, but the location does. So once these are installed, no tool is necessary to connect these onto the control board. You simply push these 2 tabs up, insert the wire, and once that's put into position, you can tug a little bit on these to make sure that they will not come back out, which basically means that you have properly inserted the cables on or into the correct position. And after that's done, the grounding can be installed. So there's a small screw that can be removed. The wire lug basically the screw goes through the wire lug, and that gets screwed on to the back end of the valve body here, gets tightened. And with that, we basically completed the termination or wiring side of this. Now, once that's complete, you can, of course, close this all back up by tightening this screw, covering the valve body cover, and installing this screw. And finally, the strain relief in the back will need to get tightened to make sure that this cable cannot be pulled for safety. Step 4 of the installation procedure will be installing the valve onto the riser pipe and securely tightening that on the tank as well. So this is just for clarification purposes, so the audience gets a little bit better understanding on how the riser pipe gets inserted into the valve. So of course, this is just for representation purposes as mentioned. So essentially, you have your hub and laterals on the bottom of the tank. Of course, gravel and media will cover this, and the valve gets inserted onto the top part of the riser pipe, which is shown here. So to show that, essentially, the valve gets inserted here, and if this is properly lubricated, the pipe easily gets installed, and the valve just kind of goes into the pipe. So continuing with step 4 here, which is installing the valve onto the tank and the riser pipe. Just for demonstration purposes, we kind of have this exaggerated where the riser pipe is coming out of the tank, but of course, in a correct installation, the riser pipe is actually flush with the top of the tank, and again, we're assuming the media has been loaded and so on. So once that's all complete, of course, the valve gets inserted here onto the riser pipe. Again, this is for demonstration, and this is a little bit exaggerated, but the riser pipe will get inserted through the center, and this will get screwed on to the top of the tank. So once the valve gets properly installed onto the tank and the riser pipe is properly inserted into the center part of the valve, it's very important to make sure that these threads are straight, and there's no cross-threading on the tank, because you're installing a metal valve onto basically a plastic tank where cross-threading can be very common and is a common issue actually. So once that's basically confirmed, of course the valve needs to be tightened. So it's about 4 or 5 complete turns until the valve is tight and properly installed. So once you get to the point where it's not easy to turn the valve, you typically want to go about a 1/4 turn and that really represents how tight the valve should be. Tighter than that can actually damage the tank and is not recommended by both the valve and tank manufacturer. Section 3 of the tutorial video will cover the programming instructions for the 3200 NXT controller. So just kind of looking at the front side of the controller here, we have a 2-line display which has various status or indications that we'll go through shortly. You have 5 buttons. Starting from the left side, we have our diagnostic button, we have our extra cycle button, we have our shift button, down and up arrows. So the purpose of the diagnostic button will, allow the operator to view flow rates, to view totalizing capacities and hours between the last generations. The extra cycle button cues a regeneration, or can also move on to the next step during the programming steps. The left button here allows the operator to, select a different character or line when programming the valve, and the up and down, of course, can change the values. So step 1 of the programming section here would be to set the local time. So our local time is right around 12:15 p.m. So to do so, you use the up and down arrows just to toggle with the setting of time. So for example, I want to increase the time, so I can just hold the up arrow for about 3 or 5 seconds, and that will get you into a set time of day section here. So to do so, of course, it's very straightforward. So to set the local, to adjust the minutes, I can hold the down arrow or up arrow just to toggle with that. If I want to change the hours, I use the shift button to get me to the correct, character I want to modify. So again, our local time is 12:15, and that's what the time has been set at. Now to exit that, I can just press the extra cycle button for 1 second, and that gets me back into, the home display. So the Fleck 3200 NXT controller has 2 different types of setting menus. We have our master programming mode and our user programming mode. The master programming mode is a much more sophisticated or customizable programming mode where every parameter of the valve can be set, from backwash lengths to different types of outputs and inputs. The user programming mode is a simpler, less sophisticated programming mode where a lot less of the valve settings can be customized. It's really geared towards operators where just certain set points can be modified, so they're not really playing around or changing very important set points of the valve controller. So to access the master programming mode, 2 buttons must be pressed. You have your shift button and the up button. Those must be pressed simultaneously for right around 5 to 7 seconds. And once you enter the master programming mode, the first setting will be changing the language. So the default is English. You can toggle through various languages like Spanish or Portuguese and so on. So we will of course keep it set at English and move on to the next step. To move on to the second step, you press the extra cycle button, and that pushes the valve into the next setting and saves whatever is selected here. So we will select English to save that and move on to the next step. We will press the extra cycle button, which is the button with the 4 arrows going in a circular fashion. Now, the second step will be setting the system type, which basically distinguishes if you have tanks operating in duplex, twin alternating, or triplex. Now our video or tutorial here will only cover system type, which is unit 4, which represents a single unit. Again, many different types of system types can be used, from 14 to 9 and so on, but we will only cover system 4 for simplicity. So again, system 4 is for a single unit, which is what we will be covering our tutorial on. The third step of the master programming mode will be to determine the regeneration type. Many different types of regeneration types exist. For example, we have a time clock delayed. We have a meter immediate if you have a flow meter installed and connected to the controller. If you want the regeneration to be queued based on the volume of water treated. And the meter delayed, it's important to note that it will queue the regeneration immediately without a delay. So once that capacity has been exhausted, the regeneration's immediately queued. The third setting type for the regeneration type is a meter delay fixed reserve, where essentially once the capacity of the system has been exhausted based on the calculated capacity and the volume treated, you can set a certain capacity in gallons, for example, like 500 gallons. So it'll delay it about 500 gallons until it queues the regeneration, in case you have other systems downstream that cannot really stop the flow of water, and once this capacity has been exhausted. So we will set ours at a time clock delayed, because we don't have a flow meter enabled for this part of the tutorial. So for the fourth step of the master programming mode would be setting the valve type. The 3200 NXT controller is installed on many different type of Fleck valves, from a 2850 to a 2750 to a 3900 or a 3150. So for the sake of this tutorial, we're going to keep it set at 2850 because that's just what this valve in particular is. But again, the 3200 controller is used for many different valves, and this must be set based on the valve type. So once that's been set and configured, we move on to the fifth step, which is setting the regenerant flow. So again, since this is a filter and not a softener, we assume it is a downflow, and that's how this valve has been ordered and configured. So that's very important. So different options exist, but since this is a filter, we'll keep it set at downflow. The remote signal start setting allows for basically an input where you can cue a regeneration. For example, if you have a differential pressure switch or other types of inputs that you would like to cue regeneration based on, that can be set here. So essentially the time is how long you want to wait until this regeneration is queued. So for example, if you have a differential pressure switch and you set this at 2 minutes, once that signal is activated, it will wait 2 minutes, and basically that signal must be held for 2 minutes in order for it to cue a regeneration. So basically a delay for it to actually regard the input. The next step would be to set the display format in US gallons. Again, this can be set in different types, in liters and gallons and so on. So we keep it set as default, and we program all our valves to be set in US gallons. The next step would be to set the regeneration days override. Now, since we have this set as a time clock, we will set, of course, the time of backwash shortly, but this determines how often or how many days are in between each regeneration. So for example, if we have this set at 7 days, your backwash will occur essentially once a week. So if day number 1 is Sunday and so on, the 7th day of the week will be the regeneration. So of course this can be changed to anything, right? For the sake of this demonstration, we're going to set it at 3, so our valve will backwash every 3 days. And of course this can be configured based on media type, application, and many other parameters that the operator feels must be taken into account. The next step would be setting the regeneration time. Again, this can be set based on many different parameters, just like the regeneration day override. If you have more than one system connected together or operating in series, for example, a multimedia filter, a carbon, and a green sand, you would want to stagger these backwash times so these systems never backwash at the same time. So for example, your media filter would be set at 12 a.m., your carbon at 1 a.m., and your green sand at 2 a.m. That's very important, so you have this kind of staggering setup so you're not backwashing 3 filters at the same time, because that would require much larger backwash systems and can possibly not allow a proper backwash to take place. So for our setting here, we'll just keep it set at 2 a.m. But again, of course, this can be changed to any time that the user feels is appropriate. The next step would be setting the backwash length or duration. So that can be changed, of course, to any setting, but we typically like to set up our filtration systems to be set at 12 minutes of backwash. So the valve will reverse the flow for a length of 12 minutes and basically push all that water to the drain. Next would be setting the brine and slow rinse. So since this is a filter valve, this actually must be set at 0. So cycle 2 brine and slow rinse must be set at 0. So this will just automatically skip this step once the valve's in regeneration and essentially totally ignore cycle 2. Cycle 3 would be setting the rapid rinse. This is where the valve is basically doing a forward flush and diverting the water again to drain. So we typically set our filter valves to 5 minutes. Which we feel is sufficient to displace the complete volume of water in a filter tank, of course based on the drain line flow control setting. And again, this can be set to any time based on what the user feels appropriate, but we really feel that the 5-minute setting is appropriate. Cycle 4 again is not a setting that's required for a media filter. So similar to cycle 2, this can be set to 0 minutes. So we will set this at 0 minutes and move on to the next step. Now, something to point out really here is if this is actually set at a particular time, it's essentially just going to prolong the length of backwash and essentially just have the system offline for a longer period of time, but it's really not going to be doing anything beneficial in terms of regenerating the system, because cycle 4 would be used for a softener or other types of systems. So we'll set it at 0 because that's the correct setting and move on to the next step here. So again, cycle 5 will also be off because that's going to be for a softener. So as shown here, it indicates that it is set as off. The next step of the master programming mode would be to enable or disable an auxiliary relay output. The benefit of this is if you have auxiliary systems downstream or upstream of this valve or filter, you would want to essentially notify the operator or other control panels like a reverse osmosis system that this valve is going into, or this filter is going into regeneration, and the other particular system that it relies on, it must be shut down. So to enable it, you toggle with the up and down arrow. We will enable it, and Pure Aqua enables this on all its systems because we typically connect these or interlock them with reverse osmosis systems, and we don't want any dirty water to enter the reverse osmosis systems while this is regenerating. So again, we enable the auxiliary relay, and from there we basically set what time or at what point of the regeneration we want the relay to energize. So for example, we typically set this at 0 minutes. So right at the start of the regeneration, it will automatically energize that relay and provide that output we need. But if, for example, if the particular application does not require to be notified or shut down a system, during the backwash cycle, you can change the time, for example, to 12 minutes, and that will only energize the output at the 12-minute mark. But again, Pure Aqua sets these at the 0-minute mark, so the relay is energized the entire time. From there, the next step would be setting the auxiliary relay output end, and that determines when you want the relay to de-energize. And again, that is basically the other end of the regeneration. So if you don't want to be notified when a rinse is in process, you can stop this at 12 minutes and so on. And this really is set based on application and auxiliary systems that are installed. But we would set this at 17 minutes. And something important to note is if once this is set at 1 minute, you can use the down arrow to go from backwards basically, and it does the math automatically where it'll add up the rinse and backwash total times. Since we set those at 12 and 5 respectively, we have a total time of 17 minutes, which is shown here. And that completes the master programming mode. And once that's done, you will see this display saying saving or configuring valve. And once that setting is done, you're back to the home screen where it says the system 4 and it says the local time, and it indicates that the regeneration is in 3 days. So now the second menu here for programming is the user programming mode. Again, as mentioned, it's much simpler. It's about 3 or 4 steps. And to access that the user programming mode, you must hold the down and up arrows 5 seconds for 5 seconds simultaneously. And once that's done, the first setting is selecting the language type. Again, you can change that between English, Spanish, or Portuguese, and various other languages. So we'll keep this set at English, and to save that setting, we move forward by pressing the extra cycle button, which is the button with 4 arrows in a circular fashion here. Press that saves and moves on to the next step. Again, the next setting would be setting the regeneration day override, which, as mentioned previously, is basically how many days in between each regeneration or backwash, and that can be set based on application and media type. The next setting would be the regeneration time, which, as mentioned, is what time once the regeneration is queued, at what time of that day the regeneration will begin. So as mentioned, if you have various systems connected together in series, you would want to stagger these times so there's no overlap in backwashes. We keep this set at 2 a.m. for the sake of this tutorial, which is acceptable. To move forward, you press the extra cycle button again, and that would complete the setting of the user programming mode and save all those settings. Section 4 of this video will cover troubleshooting and diagnostic steps. We will discuss the error type, the cause, and some quick diagnostic steps to overcome or correct these errors. So it's important to note that it can take the valve up to 30 seconds to detect an error or display that. And all errors on each timer in the system must be displayed before the errors can be corrected. 6 of the most common errors that are found on the Fleck 3200 NXT controller will be discussed as follows. The first will be if there's a matching address error programmed on the valve. The correction for that would be to program the units correctly in the master programming mode and make sure that the matching address is correct. The second error would be a flashing or blinking display, which indicates that a power outage has occurred. If that has occurred and the power is back on, no correction is needed. The third error would be a format mismatch, where different valves connected together have different units, where one valve is in gallons while the other valve is in a metric unit. And the correction for that would be to ensure that all the different valves connected together have the same display format to ensure that they're communicating properly. The fourth error would be where there is no messages displayed and small black squares appear on the display. This can be corrected by changing the display settings in contrast to match and adjust the LCD to the right contrast. The fifth error is a size error, where the units are not correctly numbered and more than one unit has the same number assigned. The correction for that would be checking that each unit is properly configured with the right unit number to make sure that differing valves do not have the same number, as that can cause a communication error between the different controllers. Finally, a communication error is common, and the correction for that would be to check all wiring in the system and verify that it is properly terminated and connected, as that can cause communication errors where wires are not properly stripped or properly connected. With that concludes our troubleshooting section for the Fleck 3200 NXT controller. Section 5 of the tutorial video will cover maintenance and rebuild kits. So a few things Pure Aqua recommends as a preventative maintenance would be to replace the control board every 2 to 3 years, along with any moving parts inside, like cams or the motors that actually move these things. It's very common with moving parts that seals wear out, motors burn, and by replacing them every 2 to 3 years, it's been proven to us that that really prevents any downtime on these systems. On the back side of the valve, we recommend that connections are inspected to make sure that everything is leak free, and if there's any leaks, we would recommend that the Teflon is redone and the fittings are retightened. Now on the drain side, for the drain line flow control, we would recommend that that's taken apart every year or so to ensure that it's clean and there's no media fine stuck on that flow control, to ensure that we're actually backwashing at the right flow rate. That's very simple. It can be taken out, rinsed with water, just visually inspected, and if it looks good, can be reused again. Now, On the inside of the valve, some seals can be replaced again every few years to ensure that there's no leakage of water during the backwash or service steps. And the manual outlines really all the part numbers for these seals, along with O-rings and various plastic components inside the valve and how to remove those. With that, we conclude our Fleck 2850 Learning Center video here at Pure Aqua, and we thank you for watching.